So this is Algebra 2, Module 4, Lesson 20. And we're looking at the margin of error when estimating a population mean again, okay? So students use data from random samples to estimate a population mean. Students calculate and interpret margin of error in context. Students know the relationship between sample size and margin of error in the context of estimating a population mean. Now, number 1 says, suppose you are interested in knowing how many text messages 11th graders send daily. Describe the steps that you would take to estimate the mean number of text messages per day sent by all 11th graders at a school. Now, of course, if you could get all of the 11th graders and ask them how many they send out, that would be easy for a school of our size that's very small, but a big school that has 400 in a class or more, that would be pretty tough. So what we would do is, if we could not get everybody, we would just do random samples of the students. Okay. So what you would need to do is find a list of all the 11th graders and assign them numbers, and then do a random number generator to, and it's, say if you're going to do a sample size of 10 or 20 or 30, you would just pull 10, 20, or 30 random sample numbers, and you would ask those students the questions or the question of how many text messages you send daily. Okay, and then you would take the mean of those and plot it, and that's all this is going to say. Probably we'll see exactly how they want it. If I could not get the responses of all 11th graders, I would base my estimate on the response of a random sample of students. Now, why can we do that? Because the sample should be representative of the population. So it should be reflective of all the 11th grade students, and therefore we could use the sample as the mean of the whole population. So I would need to find a record or a list of all the 11th graders. If I had this list, I would number all the students on it and use a random numbers to generate a random selection of students. For example, if there are 450 students, I would number all the students on the list from 1 to 450 and generate a selection of students using the random number generator on my calculator. If my sample size is 10 students, I would generate 10 random numbers from 1 to 450, identify the 10 students based on the random numbers, and ask the 10 students how many text messages they send during a school day. I would then find the mean of those 10 responses. The mean from this sample of students would be my estimate of the mean number of the text messages sent by 11th graders. That's because it should be representative of the population. Now, page 2 says, suppose that the 62 random samples based on 10 students' responses to the question, how many text messages do you send per day, resulted in 62 sample means rounded below. So what happened here? They took 10 samples from the 450 students. Okay, they did that and they found the mean 62 times. Okay, now this says draw a dot plot for the distribution of the sample means. Well, luckily you don't have to do that. There it is. If you do not know how to draw a dot plot, you need to look that up or ask a teacher. So B says, based on your dot plot, would you be surprised if the actual mean number of text messages sent per day for all 11th graders in the school is 91.7, which would be about right here? Okay. Why or why not? Well, would that surprise us? No, it shouldn't, because we have numbers that correspond from our sample means with 91.7. So that should not be any type of surprise to us. The distribution is centered almost around that. If we were to draw that almost as the mean, let me erase that. Okay, the mean would be about right there, so that's very possible because we got all these outliers down here. Okay, so see what they said. No, the distribution appears to be balanced around 92. Yep, so 91.7 is plausible. Well, it says determine a visual estimate of the margin of error when a random sample of size 10 is used to estimate the population mean number in the text messages sent per day. So we actually have to go back here to our dot plot and let's see what's going on here. So if we say that 91.7 is the population mean, so it's 91, 92, 93, 94, 95, 96, okay. So right here is the mean. All right. Let's just say that here, so we can call that 101 to, let's call it here, about 75, okay? So what we could do to make it an even number, so 91 to 101 is plus 10. If I was to subtract 10 over here, that would get me to 81. So somewhere right in there. So let's call it the margin of error would be 10. Okay, and that's true. Even though we do have some numbers outside of our margin of error, we're supposed to, right? That doesn't cover everything, but just to make it even, we would call it a margin of error of 10 because it's plus 10 and minus 10. So let's see what they did here. Almost all the sample means are roughly within 10 text messages of the population mean. So visually, the margin of error is 10 text messages on average. There you go. That's exactly what we said. Majority of them are 10 around the mean. All right, let's see what number 4 says. The standard deviation of the above distribution of the sample mean number of text messages sent per day is 7.5. Use this to calculate and interpret the margin of error for an estimate of the population mean number of text messages sent daily by 11th graders based on a random sample size of 10. Okay, so all we have to do is take that and say 2 times 7.5. Well, that's 15. So they're saying that the margin of error is 15. Okay, now, does this make sense? Well, sure. Let's go back to it. Will the margin of error make sense? Yes, it would. And it would be almost exact if we could actually take away all of these down here. Show you what I'm talking about here. If we got rid of all of this, okay, and we just looked at this, this is pretty normally distributed now, okay? And if we were to call it around the mean to be here, so this is 91, 92, 93, 94-ish, okay? So 94 plus 15 and 94 minus 50, or 95 minus 15 would get us down to 80. And this would get us up to 120? No, 110, sorry. So that would get us all the way up to here, all the way down to here. And we could see that that would be very much within the range. Okay. But let's go see what they actually said. Using the standard deviation of the sampling distribution, since 2 times 7.5 is equal to 15, the margin of error is 15 text messages. Note that the visual estimate is quite a bit smaller than the one using the standard deviation. However, they are the same if the visual estimate were to include all the samples from 77 to 107. Okay, so if we go back and look at it, they said from 77, okay, which would be here, up to 107, which would be all of that. So they just extended it a little bit farther, okay? And then that would give a few values over here to the left, And actually, we don't have any values to the right of 110. But if they left the mean at, that's them leaving the mean at 91.7 as well. Okay. So yeah, that all works out well. All right, so let's look at I thought I put the lesson summary on here. I don't guess I did.